right, we're going to continue with our experimental and theoretical probability. So get your pencils ready to fill in your notes. Take a look at the top where it says experimental probability. The ratio of the number of times an event occurs to the total number of trials. So experimental probability answers the question, what happens? So you're actually conducting an experiment. If you were going to be rolling a dice and you wanted to know the probability, experimental probability is actually what happened when you did it. Theoretical probability, on the other hand, is kind of what we've been doing. It's the probability of an event happening based on all possible outcomes. Theoretical probability answers the question, what should happen? So that's kind of what we've been doing. We've been guessing what should happen if we do this, but we haven't done any experiments yet. So here's the spinner that we have on our paper. We're going to answer the question about theoretical probability for all three of these questions, which is basically what you've been doing. So what is the theoretical probability of spinning the spinner and landing on a circle? Well, I see I have one circle. So I know I have one possible outcome for that. And out of the total, because that's what we do, we put it out of the total, 1, 2, 3, 4, 5, 6, 7. 7 possibilities. So you have a 1 out of 7 chance of getting a circle when you spin the spinner. Theoretical probability of the landing on a heart. I see I have 1, 2 hearts. 2 hearts, still out of 7. Okay. So it's your odds are a little bit better of getting a heart than it is getting a circle. Theoretical probability of the spinner not landing on a circle or diamond. So I don't want it to land on a circle or diamond. Here's 1. That's a circle, that's a diamond. 2, 3, 4, and another diamond. So there are 4 things that are not a circle or a diamond. So 4 out of 7. That's the possibilities. Theoretical is a theory. It is what could possibly happen. It isn't what actually happened. So I'm actually going to clear this screen and I'm going to scroll down just a little bit. This is where we would do our experimental probability. So we unfortunately don't have the spinners to be able to do this, but if you were conducting a spinner trial, say you're going to spin 10 times. So I want to see actually how many I did out of 10 times. So I'm going to do 10 total spins. Let's see, the first spin, I got a diamond. Can't tally it. Second spin, I got a circle. There's 1. Third spin, oh, look, I got a circle again. How about that? Fourth spin, I got a heart. Fifth spin, I got a triangle. Sixth spin, I got a plus. Seventh spin, I got a heart. Eighth spin, I got a diamond. Ninth spin, I got a circle again. And 10th spin, I got a heart. So we're just pretending, but that's what you actually would do if you were experimenting. So I've got 3 tallies over here. So my experimental probability would be how many I actually got, which is 3, out of the total that I tried, which is 10. So the experimental probability is 3 out of 10. Now, I'm not going to go ahead and do all of this, but that's kind of the process that you would do. Let's say, oh, I think I'm going to spin 15 times for the diamond and see how many times, and maybe you got it 5 times. It's just, that's the actual experiment. So I'm going to clear this screen now. Are there any results in which theoretical and experimental probability are the same? Could that happen? So there are times that the experimental and theoretical probability can be the same, but most of the time it's probably not going to happen. You do not have to answer part D. All right, so let's talk about relative frequency. Relative frequency is the total number of successful attempts divided by the total number of trials. It can be used to make predictions. As the number of trials increases, the relative frequency of an event will approach the theoretical probability. So what that means is the more times you do something, the more the probability gets close to what you predicted it would be, if that makes sense. It's kind of like if you follow baseball and at the beginning of the season, a batter's batting average is usually either really low or really high. And it fluctuates quite a bit. But the more games they play and the more at bats they get, it starts to go into more of like a middle zone. So the more you do, the more you practice, the more it's going to come out like how you predicted. So let's take this example. The spinner below is spun 50 times. And the results are shown in the table. Well, we're going to put the rest of them in there in a second. We're going to complete the experiment below by using a paper clip and pencil to spin the spinner 100 times. So I want you to pretend that we did that. Let's right now just take a look at what came up with the 50 times. So when in pretend this was spun 50 times, a 1 came up 12 of those times, which means 12 out of 50, which I can simplify that to being 6 out of 25. Okay, we're going to kind of ignore this. We were not going to do the pretending part. We're going to say that relative frequency, 6 divided by 25 is 0.24, which is 24%. The next number, so 24% of those 50 spins landed on a 1. Now, when we spun those 50 times and landed on a 2, that happened 8 times. So we're saying that's 8 out of 50, which is really 4 out of 25. So if I do the division there, the relative frequency, 4 divided by 25, is 0.16, which is 16%. Let's try one more together, and then I'm going to have you do number 4 and 5 on your own. So when the spinner was spun 50 times, it landed on a 3 13 times, which is 13 out of 50. Now, 13 is prime, so that is not going to simplify. So in our calculators, we're going to do 13 divided by 50. When you do that, you get 0.26, which is 26%. I want you to take these examples for 4 and 5 and calculate the relative frequency just the way I did it. Before you move on to the next piece, I want you to bring it up to me to show me that you were able to do it. So press pause, complete 4 and 5, come show me. So now that you have completed 4 and 5, I sent you back to your table to cross off A, B, and C. Then, as your mastery check, I want you to complete this problem 3. Bring it back to me so I can see how you did, and I will let you know what to move on to.